Section 5.3 is entitled Theorems Involving Parallel Lines. And we're going to start off here with Theorem 5.8. It says if two lines are parallel, then all points on one line are equidistant to the other line. So that means if I have a point here and I measure its distance to the other parallel line, that's the same as the distance from this point to the parallel line. Some books use this as the definition of parallel lines, two lines that are for which every point is equidistant to the other line. So everywhere we go, if we draw these perpendiculars here, the distance is the same. Okay, now looking over at example 1, it says we have 3 sets of parallel lines, 1, 2, 3. It says if RS is 12, then ST must be what? Well, we're saying here, oh, I'm sorry, I forgot to do theorem 5.9 first. If 3 parallel lines are cut off by congruent segments on one transversal, then they cut off congruent segments on every transversal. So what that means is this piece is congruent to this piece. Actually, let me slide this down a little bit so you can see it better. Yeah. What that means is if this piece is congruent to this piece, then this piece is congruent and this piece to this piece. So if we have these cut off by congruent segments, then any transversal I draw across will be cut off at congruent segments here. So example 1 here says RS is 12. So to find ST, we just say, oh, it has to be the same distance since RS is given to be equal to ST right here. Remember, we have to be given that we have some form of congruent segments here in order to know that these parallel lines are basically evenly spaced. So ST is 12, and then if AB is 8, then BC must also be 8. If AC is 20, that whole length is 20, then what's AB? Well, that's half of that, which is 10. And if AC is 10x, then BC is 5x. Okay. Theorem 5.10 says, a line that contains the midpoint of one side of a triangle, so I'm going to label this, I'm going to call this the midpoint of one side of a triangle, and is parallel to another side. We're going to say that these are parallel then. It says that this must pass through the midpoint of the third side. So our conclusion is that these two are congruent. So I'll label these A, B, and C. Our conclusion would be that AB is equal to BC because we have the midpoint on one side and we're parallel to this side. Okay? And then theorem 5.11 says, the segment that joins the midpoints of two sides of a triangle, so if we say this segment is joining a midpoint here and a midpoint here, we know two things must be true. First, these must be parallel right here. We have to have parallel lines. And the second, this segment has to be half as long as this one. So if this is 28, this piece would be 14. So looking at example 2 here, it says given R, S, and T are midpoints of the sides of the triangle. So that means right now we have midpoints. And just like before, if you look, we have RS connects the midpoints of a triangle. So it's half as long as AC, and it's parallel to AC. So as we go across filling this in, we say AB is 12, BC is 14, AC is 18. If AB is 12, it has to be twice as long as ST because it's connecting the midpoints of two sides of a triangle. So AB compared to ST, ST is half of that, which is 6. If BC is 14, then RT has to be 7. And if AC is 18, then RS is half of that, which is 9. And like we said, ST relates to AB. ST is half of AB. So if ST is 10, AB has to be 20. If BC is 15, then RT is half of that, which is 7.5, 7 and 5 tenths here. And if AC is 22, then RS is half of that, which is 11. And the last row, if AB is 10, then ST is half of that, which is 5. BC, remember, was twice as big as RT. So if RT is 9, BC is 18. And AC was twice as long as RS. So if RS is 7.8 or 7 and 8 tenths, AC is 15 and 6 tenths. And that's the end.